Hi everyone, so I'm Christian Fontaine working for Cosmos, and a few months ago, in February, I've been told that there was a new project called VPP and really dedicated not only to vSwitch but to packet processing. And well, so I was invited in the first dev boot in San Jose, and this is my story on how I got hooked within VPP. VPP for fun. Well, why? We'll just tell the main characteristics on the different platforms I run. The first, of course, x86. I wouldn't say versus, but with on Cortex ARM v7. Why VPP on ARM? And finally, if it works, a working demo. So of course, VPP is about very fast packet processing. So with x86 64, so 64-bit processors, I do have at work up to 22 cores with hyper-threading circuits with 128 gigabytes of RAM with 40 gig NICs. That's really interesting. But what if we wanted to make it run into a very smaller platform? So I had the Raspberry Pi on my desk and just wanted to know how can I get this very fast packet processing framework into a smaller device. So why VPP on ARM? Because according to me, it was a good way to get into VPP, just to play with it. It was really fun to run VPP on Raspberry Pi, and well, as we're all babies, it's always a matter of getting a square peg into a round hole. So even when we are bigger, we're doing the same thing, and maybe sometimes we achieve to do it. So, of course, for my work, I had to get with the real use cases. And of course, when it comes to VPP on ARM, I immediately thought about physical CPE. Why? Because I really think competition within physical CPE is a really good thing. Why? With user space packet processing, we may have added flexibility. When we need to add a new protocol, a new feature, it's only a matter of adding a new shared object. So no kernel modification. We don't have to wait for a specific feature getting into the main kernel tree to use it. Hopefully, we will have a better performance per watt. And thanks to this, we could push new services on the very same physical CPE. Maybe we could also extend the management tools, which today starts up to the border of the network, up to this physical CPE. And this is for the future. Today, what we could do is to keep and to stick with the existing management tools. And so, thanks to the work Pierre is actually working on, the integration between VPP and Netlink. What's the status today? What's the demo? The status is that I'm working on the Tegra Jetson TK1. It's 4 cores, 4 Cortex A15 cores. As you can see on the screen here, it's a bit ugly because there is a mini PCIe adapter up to a standard PCI adapter on which I plug a standard E1000 NIC on top of it. So let's connect to it. Okay, with it, here it is. What's the current platform? The platform I'm using is the ARM32 platform. So if you want to make it run directly on a Raspberry Pi or a Tegra or indeed any ARM v7 platform, you only have to export the appropriate platform. Just like you would do if you wish to run VPP without DPDK, so you export platform VPP Lite. In our case, we will use the platform M32. And that's it. So VPN is reconnecting. Whoops. There it is. So, indeed, now I already compiled everything because even if it's Cortex-A15 running at 2.3 gigahertz, getting everything from source and building just takes some time, so just prepared everything. And so, what do we have? If I look at the configuration file, I'm using the plain startup.conf. I'm using the DPDK for ARM. I'm using the UIO PCI generic, but of course I may use IGB UIO. Everything is working as expected. And as usual, I'm specifying the PCI address of the NIC I want to use. In my specific case, because on this specific platform I only have 2 GB of RAM, and I had to make some fine-tuning about the compilation. So if we look at the build data platforms, ARM32, what do you have? Within the process of making VPP, compiling directly into the Raspberry Pi on the Tegra, I had to make some modification related to the build process. One of the modifications, of course, is to add the ability to add the specific configuration variables in order to build the supplementary drivers, because those elements are by default disabled for ARM platforms, for ARM v7 platforms. So thanks to this, by adding the extra args, I enabled the IGB UIO and some NIC drivers. And so it just works. Also, we have to modify and to specify the heap size. We have to modify the maximum number of cores, etc., just to reduce the memory footprint of VPP. And if I look at the mem info, as you can see here, with this specific kernel, the huge page are enabled. So if you happen to have Jetson TK1 running the vanilla Linux for Tegra, rootfs and kernel, it's running the kernel 3.10. So what you will have to do is just to pull the latest kernel. So I'm using the kernel 4.5.3, I think. So let's check. That's it. So in order to enable huge pages within this specific version of Linux, we must enable LPIA, so the large physical address extension, in order to get enough TLB space, etc. But at the end of the day, what we have is that we have some huge pages, we have a lot of memory, we have a PCI NIC, so everything works. So here, if I just do a show int, great. I do have my NIC running on VPP inside an ARM platform. What can we do with it? We will first set the interface up. We'll specify the IP address, 20.161, for instance, /24. So everything is up, and now we need to generate some traffic. So at the other end of the cable, I do have my my workstation, and I will just launch Scapy and a T-Shark. I could have used TCP dump, but whatever. Oh, now I see that the interface is still down. Well, I asked to set it, and okay, that's good. Now, IP probe neighbor. So, and the specific command is IP probe neighbor, the interface name, and some IP address. And good. Now with IP probe neighbor, what I see is that I do have some packets getting out from the VPP to the network. Good. And edit. Sure. Oops. Should have done Control C. So for this, send interface IP address. IP probe. Oui. Merci. I really need to stop Control C. But at least we can see that everything is working as expected. Okay, but something is weird, and the resolution failed for 20.1. Why? Okay, still down. Okay, and now on the top right, we can see that we got an answer from the workstation. Good. Still, in our case, doesn't work. So what's happening? Let's see some counters. Show run. So wait. Yes. So good. We see that indeed we got some packets within the output node. So within the takes, we see the number of calls and number of vectors. But what I did not see here is the input node, the DPDK input node. Why? Indeed, that's still a bug. I'm still working on it because due to some cache behavior between the Cortex A15 and the memory controller and the NIC interface with the DPDK, I still haven't managed to receive real packets from the hardware now. So, well, I may have some workaround, but still a work in progress. Well, what are the lessons I learned? First of all, when I had to port the code from 64 bits to 32 bits, those usual porting problems happen. So please do not assume a UWorld is equal to 64 bits. I would say that on the patches that submitted, 99% of the problem had, well, 95% of the problem had was related to those kind of casts. The second problem is that something I honestly do not like within VPP is that we didn't have enough semantic within the structure definition. So in order to make some pointer computation, pointer arithmetics, they do not use int pointer. We just use uword or u64. So in order to improve this, some macros or inline functions exist. So please use pointer to uword and uword to pointer so that we add semantic within the code. Beyond those macros, those are only static casts. So for all the performance related matters, it's exactly the same, but at least we have more semantic. So what do we have today? Today, ARM32 platform is just working in upstream, no cross compilation. You just have to export the platform to ARM32 make build. So maybe you will have to make some modification in order to disable DPDK because, for instance, on Raspberry Pi 3, this just doesn't make sense to have DPDK because the Ethernet is connecting on the USB ports. But for other platforms, such as the Tegra, this could be relevant. One thing I didn't do before running VPP on Tegra is to run testpmd first. I should have. So please use it, and well, it's way better for you. And finally, what I learned also, but I already knew it before, is that there is a really awesome community on VPP. It's really interesting to work with them. Damian and Dave are really responsive when we send emails, and well, it's really interesting. So what's next? RX support, of course. I'm being honest. Within the DPDK driver, I may have a workaround. I will try to work on next week because with the RT malloc today, the memory is marked as cached and not uncached. So maybe that using DMA alloc currents may correct the bug I have, but maybe not. I have to try. Also, Damian told me that there will be an integrated VPP driver for E1000 NICs. So, we'll see. When those problems are resolved, we'll be able to focus on performances. And, well, we have Tegra K1, we have Kepler GPU, so we have 192 cores, which are just sleeping. So, of course, we may play Doom with this, but from my perspective, it could be interesting to do some kind of offloading, and I'm specifically thinking about IPsec.
Why do you think it would be useful or not to have the E1000 driver in VPP? Because I'm not sure. I mean, right before you, there was DPDK. The DPDK guys would like to have all the drivers in DPDK. So why would we put a driver in VPP?
I specifically think about memory footprint. In order to have a smaller binary, in order to have something which is maybe easier to deploy, and maybe we could have some platform which do not rely on huge pages to run. Because DPDK really relies on huge pages, and if we may run without huge pages, there is a huge benefit for me, is that I could run VPP without my own kernel. Because today, what is limiting me today is that I have to run a custom kernel, and so I cannot run NVIDIA-provided drivers. And that's my main problem today. So either someone will be nice enough to backport huge pages on the kernel 3.10 for ARM, or if I'm able to run the VPP without huge pages and still being able to use PCI drivers would be awesome.
I think first thing is that on 3.10 you should be able to have huge pages, no?
Yes, Excepted that on 3.10 for ARM, it's not
ARM is
yet.
there,
Yes,
okay.
the huge pages are only available from 3.12, I think, or 3.13.
Another point about the native driver, which is something we have, and I was planning just to put into the repo just for a demo purpose, so it's not intentional really to use that one as a primary E1000 driver, but the point is that even for that driver, we need the huge pages.
Okay, so well.
So that will not fix the problem.
Well, thanks. We'll have someone to backport the huge page to the kernel 3.10.
Will that driver be polling mode or as well support interrupt?
It's interrupt. So yeah, I mean the driver is basically very similar to IXG driver, which I submitted 2-3 weeks ago. So it's basically very similar code, and it's something we have from before. I mean, there is no intention really to write new drivers in VPP, but I mean, it's a nice it's a good sample how some hardware support can be built inside the VPP. So that's the reason why I basically put it there.
Yes, indeed, it would be awesome to have some kind of example in order to be able to leverage integrated NICs in other ARM socks. Yeah.